Hello everyone, my name is Colin Kerr, and this is a talk about data in your digital twin. This is not a talk about OData, regardless of what the title of this page might say. This is a talk about what an iModel is, how data is structured in an iModel, and how to query for it. Got a lot to cover, so let's jump right in. First off, what is an iModel? An iModel is a SQLite file. It's got a fixed table structure that we've designed for maximum performance and scalability. And we've put on top of that an extensible metadata layer so you can see your data in a friendly way that makes sense to you, and you can query it with really powerful language we call ECSQL. This extensible metadata layer on top of the database is called BIZ, or the Base Infrastructure Schema. It provides an additional set of semantic meaning on top of the tables in your database, and it's consistent across engineering disciplines and boundaries that might have previously existed in your data due to things being in different files and having different file formats. When we query in ECSQL, we're basically taking standard SQL and we're adding our little richness class layer on top of it. When you're accessing an iModel, you can use Bentley's open source libraries, and you can use our services to create custom applications and custom services that leverage the power of the iModel and connect it with the rest of the information in your digital twin. For this session, we're going to be using a free account that you can set up and the sample iModels that are part of the iTwin platform. Really quickly, if you're not already signed up, you can go to developer.bentley.com to sign up. Once you're there, you can go to the registration dashboard and add a sample iModel to play around with. In this case, we're going to use the Baytown process plant sample. It's a small little sample, but it's got some good data, so we can really dig into it. As part of this course, we're going to look at a simple sample application called the iModel Reporter. It shows you how simple it can be to use our iModel open source libraries. We're also going to be using the iModel console and the iModel Schema Explorer, which are tools that you can use with a developer account. All right, so let's hop right into it and ask, what is BIZ? Okay, BIZ is a set of object-oriented relational schemas that define the data in an iModel. Now, there's a couple of core concepts that you have to understand before we talk about what's actually in a BIZ schema. The first one is entity classes. Entity classes are like a table in a standard relational database, but they add inheritance and polymorphism. Next, we have relationship classes. These are like link tables or foreign keys in a standard relational database, but they also add inheritance, polymorphism, and each relationship lists an entity class on each endpoint, so it's strongly typed. When we look at a particular entity class, like in this case element, you can see it has property definitions, and one special and very important type of property definition is a navigation property. The navigation property defines a foreign key, and it uses a specific relationship. It references a specific relationship in that foreign key property. The one final type of thing that we need to bring up here is a mixin. A mixin is an abstract base class, essentially. It can be applied to an entity class. They can be relationship endpoints, and it's the only part of the whole system that allows any multiple inheritance. So an entity class can have only one base class, but it can implement any number of mixins. And one final thing to note, when we talk about a row in a relational database, I'll often talk about it as an instance, and that's because this is an object-oriented relational database paradigm, and so sometimes it's really helpful to talk about things as instances instead of rows, and we leverage some of that power when you get into our iModel libraries, which we won't delve into too much today, but it's there and it's really cool. You should check it out. Now, let's dive into the core BIZ concepts. There are only three that are really important, and you have to know. The first is element. Element is the base class for all classes that hold data in an iModel. If you're storing any data, it's going to be an element. So there can be a lot of elements can see here, there's a couple derived classes. We'll dig into that a little bit more later. And if you want to extend an element, you can use an element aspect. It adds a set of properties to an element. They're not on the element, but they're owned by the element. And there's two special types of element aspect. One is unique aspect, where there may only be one instance of an element, particular element aspect class per element. And there's multi-aspect, where there may be any number per element. They are connected back up to their element using a navigation property, and the element owns multi-aspects or element owns unique aspect relationship. The final class that we really have to know about is model. Model is a container for elements, and each model describes some other element in more detail. Now, we've covered these three topics. Those are the basic things you really have to know to work within an iModel. There's a couple secondary topics that are really quite important when you want to actually dig into an iModel, and we're going to reference them today. So let me go through them now ahead of time. So the next one I want to talk about is physical element. Physical element is the base class for anything in an iModel that exists in the real world. It exists in space, it has mass, it can be touched, okay? The next thing we want to talk about is functional element. Functional element represents the behavior or the requirements of a particular object in a system. Now, you might have a physical and a functional element representing the same thing. The physical element represents the actual object in the real world, and the functional element represents the specifications it must fulfill to be successful in its role. Now, let's look at a couple properties of element. First one I want to bring up is, well, it's three properties together. It's the code value, code scope, and code spec. Kind of think of it like a tag from a plant management system. It is a unique human readable identifier that an element may have. It doesn't have to, but it might. And you'll see it used quite a lot, especially in things like plants. The next thing I want to highlight is a type definition. It's used quite often when an element is from a catalog, because catalog has a catalog item that you get ordered in has a bunch of immutable properties that you can't change, and we represent those values via type definition. And you can see that's a navigation property. Next, we've got category. You can think of a category as like a level in MicroStation, a layer in AutoCAD, or a category in Revit. Any element that can be categorized will have a category navigation property. Next, I want to touch on one very special relationship that we use all the time for a lot of different things, and that's the element to refers elements relationship. This is basically, it defines the most commonly used link table within iModel. At either endpoint is a relationship, and we specialize it in all kinds of ways. Like, for example, here's physical element fulfills function. It connects a physical element and a functional element there. Now, one last thing before we dig into it, I want to highlight the subject class. We're going to see that in a moment, but the subject class defines the top level hierarchy of an iModel. Let me jump over there now. So if you see here, we have a example information hierarchy in an iModel. We have our repository model. Inside of it, there's a bunch of subjects, which defines in increasing levels of detail what we're going to model, and then we actually jump into the physical models, the functional models that actually hold the data in the system. So you can almost kind of think of a subject as your index. That's not exactly true, but it's close enough. So now I want to talk about the iModel file structure, and for that I'm going to pull up a SQLite browser. If you're on Windows, you'll probably use SQLite Expert or something like that. But I just want to show that an iModel really is just a SQLite file, and I'll show you the tables that actually turn it into an iModel. So the two main groups of tables I want to talk about today are the BIZ underbar tables and the EC underbar tables. So if you look here, you can see BIZ underbar element, right? Or BIZ underbar geometric element 3D. So these are the core tables that'll store most of your data in an iModel, and they're structured in a way that lets us do really fast joins and have link table relationships that are fast to query across many different types of class. And we'll just dive in here and take a look. You can see here's columns of the element table, and they match up pretty well to the properties you see here when we look at the actual class definition. Now, if we look at something like the geometric element 3D table, you can start to see some of the magic we do to support an almost infinite number of classes inside of a single database. So here you can see the geometric element 3D table. So physical element will go into there. A bunch of these properties, well, they make sense, right? They are easily legible. They have a type that's reasonable. But then we get down to these guys with kind of arbitrary names, and they're of type blob. So what we do in each row of the database, we might use one of these columns for a different property from the schema. And this lets us have narrower tables than we might otherwise have, and it lets us store more classes in the same table, because you can't have too many tables and you can't have too many columns. So this really helps us keep the number of tables and columns down while having tons and tons of classes with many different varying properties. So those are the BIZ tables. The next set of tables that I want to talk about are the EC tables. The EC tables are what let us turn that really normalized, performance optimized table structure into something that an average person can, or even a superhuman person, can make any sense of. So the EC tables define all the metadata information from a schema, plus all the mapping information that maps from that schema into the actual database tables that store the data. So that way, if you say, select from pipe, we know what table to go to. We know how to map all those columns back to the actual properties that you have in your pipe class definition. So with that out of the way, I want to jump back and actually dig into actually exploring a particular iModel. So to do this, we're going to open an iModel in the iModel console, and we're going to I'm going to just skip over this stuff here. It's explaining how to do it, and hop right into the basic queries. I'm going to go into iModel console. I'll select plant, and I'll select the specific change set. Now, because this is a sample data set, there's only one change set, but in a real iModel, you'd see many change sets. Now, once we have the iModel open, we can start to do some queries. So the first query we're going to do is your most basic query. Select star from BIZ element. If you remember BIZ element, it's the base class that all data comes from. So if I do this, you're going to see here we have a whole bunch of classes, a whole bunch of rows, and we can see some data here. We can see here's code, here's parent. Okay, now the next thing we're going to do is let's get a count of all the elements. Sure, okay, we show it to you here, but that's just some nice UI. So you can just see this is basic SQL, right? The only difference here is that I'm talking about a class instead of a table. The next thing we want to do is let's see how many of each class actually exist in this iModel. So we're going to paste this in here, and you can see that this is once again all pretty standard SQL. The only thing that's kind of special here is this EC class ID. This is a 64-bit ID in our database, but when we show it to you here, we're converting it into a friendly text string here. If you want to see the actual ID, we can just name it ID, and you can see there it's actually a hex value. 64-bit IDs are incredibly fast in SQLite, and we leverage that quite a bit to make this performant. So you can see here we've got ports, welds, pipes, gaskets. See here we've got some functional elements as well. Now let's select pipes because we're in a plant, so we might as well select pipes, right? So when you see a select pipe, we're actually going to get a lot more properties than we had before. So if we scroll over here, you can see these are all the ones that we saw before: parent, GUID, category. Now we've got category, spatial index, origin, yaw, pitch, roll, bounding box. We actually have, that's the geometry scheme. That's actually the data the graphics that you see. Now we're getting into all the properties that come from our process schemas, okay? Now, previously, I was talking about the element first elements relationship. Let's query that, because you can query this just like any other class. Just think like a link table that you might query. And you can see, once again, have an ID. Every element has an ID. Link table is no different. And you can see the link table has the source ID and the target ID. These are the IDs of the elements that it's relating to. So now let's try and find out which elements are related to pipe. Okay, so we know there's pipes. We know there's the element first element relationship. Let's create a query that tells us what pipe's related to. If you take a look at this here, we're leveraging one other cool thing about EC, the EC part of SQL. We have this is operator, and we're listing the actual name of the class. Now this is polymorphic, so if there's any elements which derive from pipe, they'll be caught up in this as well. And just one quick note, join here, this is an inner join. If you ever want to think about doing an outer join, that's a left join in SQLite's syntax. And I've got a link here. This type filtering is actually really cool. You can do a lot of stuff with it. We're using a very, very simple form of it here. So I paste this in, and you can see pipes are referenced by ISO sheets using the ISO sheet has device relationship. So that's interesting, but let's gather some information about pipes, because part of the idea here is like maybe we want to do some quantity takeoffs, maybe we want to understand some more about the pipes that we have in our iModel. So here I'm just going to select the line number, the length, and the weight of, oh, I forgot to copy out the P portion. Okay, so you can see here there's a lot of pipes in the same line, and that makes sense, right? So what if we want to sum up the lengths and the weights of all pipes in a particular pipeline? So let's do that. Now I'll note real quickly here, we're using sum, which is pretty standard stuff in SQL, and we're using group by, also pretty standard. Okay, now you can see for each individual pipeline, we've got the number of pipes, we've got their total length, and we've got their total weight. But what if we also want to understand the types of pipes and do the counts by that? So I'm going to pick component name, and we're going to group by that again as well. So that's just another group by statement here, and you can see now we're grouping by not just line number, but also by components. So you can see here's the first line number. There's two different types of components in there. We can get the length and the weight and the number of each one of those. So that's some quick dive into some things you can do when you query an iModel. Now let's dive into how you can explore the schema, because really, to be able to do these queries, you have to understand the schemas that are in your iModel. So to do that, we are going to use the Schema Explorer. So let me hop over to that page here. Okay, so there's two ways to get to the Schema Explorer. I've already got it open, but you can type .schema, or you can go here and click Schema Explorer. I'm going to open it. This will open the Schema Explorer for this exact iModel. So I'm going to get exactly the classes and schemas that I have in my iModel shown here. If you just go to iModelSchemaEditor.bentley.com, you see all of the standard schemas. Okay. So the first thing we're going to look at is how do you browse around in the Schema Explorer. We looked at it before. This lets you select everything that exists in the schema. In all the schemas that are open, you can see all the schemas that we have right here. If you select any particular schema, you see the contents of that schema, and if you click on any particular thing, it'll take you to it. Now, that's one way to find stuff. Another way to find stuff is to search. So we were searching for pipe before, so you can see here, here's all these classes that we have from pipe. You can see here there's the functional and the physical schema, so there's two different versions of pipe. As I referenced before, one represents its physical representation, the other one its functional representation. Now, if we, we'll just pick pipe here. If you, in the left-hand bar, you can see the hierarchy for any particular class and where it is. If you look at the list of classes, at the class that you have selected, you can see the list of properties, and you can see where those properties come from. So you can see here's some from element, geometric element, and we go all the way down, and once we get down to the bottom, we can see pipe just adds two properties, which makes sense, right? Because we want to have data that's well aligned, and well aligned data has common properties in base classes. So now I'm going to take a look at a relationship definition, because those are quite interesting as well. So I'm going to look at the element owns child element relationship. And if you see here, we show a UML-ish like diagram that shows the two constraint classes. And because this is a navigation property, you can see that we list the navigation property for that element. Now, I'm going to click over here on physical element fulfills function, just to bring this up again, because we're going to be talking about this shortly. But you can see that this has a differentiation in the endpoint. So we know that the source of this relationship will always be a physical element, and the target will always be a functional element. That's really helpful when you're doing queries and you're trying to make an application. So that's a quick overview of the Schema Explorer. And I just want to plug again, search is your friend, because it can be hard to find something if you're not sure exactly where it exists in the hierarchy. But that's not all. There's more. We can explore schemas straight up in the iModel console. We do that with the ECDB meta schema. Now, this schema is in every iModel, and it includes classes which represent the data stored in the EC table. So you can see here's EC class def, EC schema def, EC property def. Those represent the classes in the EC metadata in the iModel based on classes in this schema. Now, one thing to remember here is EC class def, there's going to be instances of it. Those instances are the classes themselves. So the instance ID of the class def is the same as the class EC class ID of any other instance. Okay, so let's take a look at that. Okay, so I'm gonna go back here, get to my queries. And first thing we're going to do is select all schemas in here. Now you'll note these schemas are the same basic schemas that we saw in the previous view. The next thing we're going to do is let's select all classes in here, all entity classes. Now here's a class type. This is an enumeration, and so if we go over here, we look at class type, we click over, we can see it's strongly typed. I'll note mixins are essentially abstract entity classes, so they're not handled separately here. So I will paste this in. And you can see here's all of our classes, name, display label, all their relationships. But this is a little bit confusing. I don't want to see these. I want to see my BIZ classes, right? So we're going to pull out this guy here. I did it this way because I want to show, just like many other SQL languages, you can have nested select statements. You could also do this by joining with the EC schema def table. There's a lot of different ways to do it, but we'll do it this way. And you can see now we're seeing just classes from the BIZ schema. Okay, now remember how I said earlier that the instance ID of an EC class def is the same thing as EC class ID. Well, here we'll show it, and at the same time show off a really handy dandy function that you can use anytime you want to get the fully formatted class name from an ID. So we do it for you automatically here in the iModel console, but when you're querying a database, you won't always want that done automatically. So you can do it on command, and you can also do this in the where portion of a query. So for example, I can use this EC class name function in a query like this, where I am essentially rewriting that query above here using a special format string for EC class name. And it's going to provide me the same thing that I did in the previous query where I had the subclass. Now, you can take a look. We have in our ECSQL tutorial, we have a whole section on these built-in functions. There's a lot of cool things you can do with them. The second one of these really cool functions here is EC class ID. It does the inverse of EC class name. So if we plug it in here, you can see that we list biz.element and we want to get a class ID. And sure enough, it selects element when I pass in biz element as the class ID. And remember again, anytime you see EC class ID, that is the EC instance ID of that EC class's definition. Okay. Now, let's get a little bit more complicated here, because we've looked at classes and schemas now, but we also have to take into account properties. Properties are obviously where all the data is, but they're because we have inheritance, you have to do something a little bit more fancy to query for them. So what I'm doing here is I'm just going to select all the properties that are defined on named item. And if we go here and look at named item, you can see that it's got a bunch of properties. Only 2 are defined in named item. The rest are inherited. If we go over here, you can see, sure enough, when I said select the property definitions that belong to named item, I got 2 properties. Now, how do we get all the inherited properties? Well, there's a really cool relationship called class as all base classes that flattens out the inheritance hierarchy, so we can get all the inherited properties without doing a recursive query, and has the first entry for this relationship is always the current class. So we don't have to do anything fancy. We can just join with this relationship and plug it in here. You can see we get the properties that we saw in the Schema Explorer. Now, if I'm going a little fast for you, don't worry. All this stuff can be found online. There should be a link in the notes for this session. Now, we've played around with some queries. We've done this stuff. Now let's actually do something useful. We're going to make a report. To do this, we're going to use our sample application called iModel Reporter. You got to have Node installed. I suggest having VS Code. You also need Git. So you clone this repo, open it up in VS Code, and take a look at the example queries. Now, let me hop over to that myself. So here is the repo. Here's our example queries. I've actually pasted in all the ones we're going to do later. Ignore those. But you can see it's a simple JSON file. It lists the URL for the project, and we parse that to get the information. So when you're actually running it, you can do that yourself. This is to my sample project. And we've got a store and a query. The store is the file that's going to be used, and the query is the query that's going to produce the file. So this example produces a CSV file based on your query. Now, like anything else, you're going to do npm install, run build, then npm start, run start, and you're going to list the example query. Now, if it's the first time you've done this, or the first time you've done it in a while, it will pop open a browser window and ask you, are you sure you want to do this? Say yes. Once you said yes, you can just close that window. It will download the iModel and execute the queries, and it will save that iModel off, and it will only download it again if you specify a different iModel. Now, what's the report we're going to create? Well, we're going to query the same plant iModel and come up with these 4 queries. One is the sum of dry weights by devices by class and by category. And we also want to identify all the devices that do not have a dry weight set or have the dry weight set to 0. Now, that might be fine, but this is a good way that we can kind of check the quality of the data, and we can do it really quick. We can get a report. Anytime the iModel is updated, we can run the report again, and we could, add some exclusions to it really easy because it's a SQL query. Now, the next thing we're going to do is we're going to connect the functional element and the physical elements in this model and show the two together. And then we're also going to identify any functional or physical elements that don't have their corresponding partner. So functional element doesn't have its physical element, or physical element doesn't have its functional element. Now, because we're doing this live, you won't have a chance to think about it, but and I've got all the answers for you right here. But let's hop in and I'll explain them really quickly, and then we'll run them. Okay, so the first one, we want to get the sum of the dry weights. We want to show what class it's from. We want to show what category it's in, and we want to get the count of the count of elements that are included in a particular grouping. So we're going to select from process physical device. Now remember, we're polymorphic here, so anything that derives from device will show up here, whether it be a pipe or a valve. And then we're going to join the category into it. Remember, we're using the category navigation property. The ID is the ID of the category instance, and that's what we're doing here. Then we're going to group by category ID and class ID. Next, we want to find things that don't have a dry weight specified. So this one's real simple, right? We're using where criteria, and we're saying where dry weight is null or dry weight equals 0. Easy. Next one. This one's a little bit more complicated, but at the end of the day, it's still pretty comprehensible. So we're going to select the class name, the description, the user label for both the functional and the physical element. We're going to use the functional physical element fulfills function relationship. We're going to join into the process physical and process functional schema, and I'm using some of the knowledge I have of these schemas to know how to do this. But remember, this is what the Schema Explorer is for. This is what the metadata queries are for. It lets you really dig in and understand what the data model is in your iModel, and so you can do this too. So this will I'll actually show this one because it's pretty interesting. I'll show it in the iModel console because it looks better than a CSV. And so you can see here we've got a piping network system has a corresponding piping physical piping network system. If we look, here's a gate valve, a functional gate valve, and it's got a physical corresponding valve. Okay. And finally, we want to identify anything that does not have that link. This is another data quality thing. Sure, some might not need to. We can always revise this. So I've done a subquery here, so you can see you can keep adding where criteria into this if you'd like to restrict it more. So I've got these queries. Now let's hop back over into the iModel reporter. We'll take a look here at the JSON. You can see I added all these guys here. They're not super easy to read. That's why we looked at them over there. And now I've already run npm install and build. So run start sample.json. So we're opening the iModel. We've already downloaded it and we've already written them out. So you can see, I mean, these aren't a lot of rows, but you can write quite a lot of data out of here. And we'll just take a look at the output files here. We'll look at dry weights. You can see here we've got 51 nozzles and they have no dry weight. That may very well be fine because you're not trying to get quantities off of it. But you can see here, you know, a lot of stuff does have weight. We can take pipe here. Good example. Okay. Now, one last thing before we complete, I want to show you how easy it really is to write an application like this. So let's take a look at the source code for this application. I'm going to skip the source code that digs into actually writing out a CSV file because that's just writing a CSV file. And I'm going to focus on actually working with the iModel. So this first bunch of code here, this is how we handle sign-in. It's pretty straightforward. Now let's get into the main application. So we say iModel host startup. That starts up iModel.js. We do the sign-in using the method I showed above. This code here, this is all me parsing the example JSON to get the project ID, the iModel ID, and the change set ID. This is just some fancy progress tracking stuff. So as we download it, we show you how fast it's going. And that's helpful if it's a larger iModel. Now, here we're downloading the briefcase. That's all you have to do. Here you're opening it. Pretty straightforward. This is where we're running through everything, outputting all the files. And here's where we're shutting down. I'm going to jump into the exporter really quick and just show you what it looks like to query it. So all this stuff is just working with iModel. Here's where we actually created the iModel. So here's iModel DB with prepared statement because we're executing a SQL statement. We're stepping over the rows and we're writing out the data. It's that simple. It's that easy. And this is a great example because there's very little filler, very focused. Okay, that is everything that I have for today. I hope you enjoyed it. And yeah, check it out. Check out developer.bentley.com. You can check out everything I went over today by going to either this GitHub link, GitHub.io link, or the actual repo that we put in the On24 session. And thanks a lot.